You know, the world's most powerful AIs, they're like digital giants. They live in these massive, power-hungry data centers. But how in the world do you take that genius and cram it into your pocket without losing what makes it so smart? Well, today we're diving into a really clever process that does exactly that. It's called AI distillation.
It really feels like a contradiction, doesn't it? I mean, think about it. The AI that can write a symphony or, discover new drugs, it's trapped up in the cloud. And the reason is pretty simple, really. They're just too big, way too slow, and they absolutely devour power. Your phone just can't handle it. This is the core problem we have to solve.
So here's the fundamental clash, right? In one corner, you've got these massive AI models. They're unbelievably powerful, but they need a ridiculous amount of computing power to run. And in the other corner, you have the device that's right here in your hand. It needs things to be instant, and it definitely can't have its battery drained in 5 minutes. It's like they're from two different universes.
But here's the really interesting part. This isn't a story about AI failing. Not at all. It's actually a problem that comes from its own insane success. The smarter and more capable these models get, the bigger and more expensive they become to operate. Yeah, you could totally call it AI's growing pains.
And just to give you a sense of the scale we're talking about, it's absolutely staggering. The AI market, it's projected to grow by almost 37% every single year through 2030. But that kind of growth just can't happen if every single AI needs its own private data center to function. So solving this size problem isn't just a nice to have, it is absolutely critical to unlocking that future.
Okay, so how do we fix this giant problem? Well, the solution is, believe it or not, surprisingly elegant. And it's all built around an idea that every single one of us gets, a teacher and a student. This simple metaphor is the absolute key to making giant AI tiny.
This whole process has a name. AI distillation, or sometimes you'll hear it called knowledge distillation. And the core idea? It's brilliant. Instead of trying to build a tiny model from scratch and just, hoping for the best, you have a massive teacher AI pass its wisdom directly down to a smaller student AI. So the student isn't just learning from a textbook, it's learning from a seasoned expert.
All right, first up, let's meet our teacher. This is the big one. A massive, super complex AI that's been trained on just astronomical amounts of data until it's a true master of its subject. Just picture a brilliant, wise old professor. Incredibly accurate, knows everything, but maybe takes a little while to answer because, they're considering every single possibility.
And now for the hero of our story, the student. This model is the exact opposite. It's small, it's nimble, it's lightweight, and it's specifically designed to be fast, even when it doesn't have a ton of power. On its own, it's not an expert, but it is an incredibly eager student, just ready to soak up all that knowledge from its teacher.
So this is where it gets really cool. How does this knowledge transfer actually happen? Because it's not just about the student copying the teacher's homework. No. The way the lesson is taught is way more sophisticated, and honestly, it's fascinating.
It really comes down to 3 key steps. Step 1. The teacher model does its homework. It trains on all that data until it's an expert. Step 2, and this is the secret sauce. The teacher doesn't just give answers. It creates a really detailed lesson plan, what we call soft targets. And then finally, step 3, the student learns directly from that rich, expert lesson plan, not the original raw information.
Okay, so what in the world are these soft targets? This is the real magic of the whole process. See, a regular AI might just give you a black and white answer, like, that's a cat. But the teacher model gives a soft answer. It says something like, I am 98% sure that's a cat, but there's a 2% chance it might be a small dog. That little bit of uncertainty, that nuance, that is what's so valuable. It teaches the student why an answer is right, not just that it's right. It's teaching the reasoning.
So after all this brilliant teaching, what's the result? What do we actually get out of it? Well, the payoff is it's a total game changer. You end up with an AI that is dramatically smaller, incredibly faster, and yet it keeps all the genius of its giant teacher. Let's look at the results. So, benefit number 1, size. And this is a big one. We're talking a massive reduction. These student models can be more than 90% smaller than their teachers.
This is literally how you take an AI that needs a whole server and shrink it down to run on a tiny chip in your phone.
Okay, but a smaller model has to be dumber, right? What about performance? Well, this is the most mind-blowing part of the whole thing. Even after shrinking it down by 90%, the student model holds on to 95 to 99% of the teacher's original accuracy. Think about that. You get a tiny model with a world-class education.
And the wins just keep on coming. It's not just about size and smarts, because a smaller model is also a way more efficient model. And that means huge savings. We're talking about slashing computational costs by up to 80% and cutting energy use by 70%. This makes AI not just more affordable, but a whole lot greener too.
Okay, this isn't just some abstract idea in a lab. Let's talk about where this is actually showing up in the real world right now. Distilled AI is powering faster medical image analysis for doctors. It's behind that instant fraud detection on your credit card. It's helping self-driving cars see and react in the blink of an eye. It's even making characters in your video games smarter without causing any lag. This stuff is already all around us.
But believe it or not, the story is far from over. This is a field that's moving at lightning speed, and researchers are already cooking up the next generation of these techniques to see just how powerful tiny AI can really get.
And just listen to some of these ideas on the horizon. They are wild. First, there's self-distillation. Get this, a model becomes its own teacher to refine itself and get even smarter. Or how about online distillation, where a student learns on the fly, in real time as new data streams in? And then there's multi-teacher distillation, where a single student model can learn from a whole panel of different expert teachers.
And all of this brings us to the final and maybe the most important point, because the real power of AI distillation isn't just about the tech, it's about democratization. It's about taking AI out of these giant, expensive data centers and putting it directly into the hands of innovators and creators everywhere. It makes AI personal. It makes it efficient. It makes it accessible to all of us. So the question I want to leave you with is this. When genius-level AI is this small, this fast, and this accessible, who is it going to empower next?